All right, Math 201 students, this is the pre-video for section 5.2. We're going to be looking at how to take the integrals of exponential functions and logarithmic function, or the function that has the natural logarithm as its antiderivative. So the first thing is we have to go over our rule for the integrals of exponential functions. It is that the integral of e to the x is dx is e to the x plus c. We knew the derivative of e to the x was itself, so if you're taking the antiderivative, it's still itself, but it could have had a constant, remember, that drops off when you've taken the derivative. So we're going to do the odds here. So this is number 1. It says 2 e to the x dx as an integration. So remember, if you have a constant, you can pull that out to the front if you need to. So this is just the integral of e to the x dx. So the integral of e to the x is e to the x, so times 2 plus our c. So there's that first one. Now the next one's a little different because it's not just e to the x, it's e to the 5x. So we're going to use our technique we learned in section 5.2 called u substitution to make this look like e to the u. So we're going to let u equal 5x, then du would be 5 dx. I will regroup my integration. This is e to the 5x times 5 dx. So we've already got our du. So this is e to the u times du. So the antiderivative of e to the u would just be e to the u plus c. And then we put back in our 5x. So this is e to the 5x plus c. All right, for number 5, we have another one where we have something in our exponent, so we're going to use u substitution again if we can. So this would be u equals 3x plus 1, because that's my exponent. Du would be 3 dx. So notice this has no 3 out here, we have just dx, so we're going to have to do divide both sides by 3 to get that 3 to go to the other side. So du over 3 is just dx. So we would write this as, this is e to the u times du over 3, bring the 1/3 out, then it's e to the u du, and then the antiderivative of e to the u is e to the u, so 1/3 e to the u plus c, which we can replace our u back to the 3x plus 1. So 1/3 e to the 3x plus 1 plus c. All right, so that is the ones dealing with e to the x. The next ones are if you have, and this is where we are going backwards for natural log. So when we learned about the derivative of natural log, we learned that it was 1 over x, or 1 over the inside of the natural log times the derivative of that, if you had a chain rule. So if you're doing the integration, you're saying that 1 over x dx, the integral of that, goes back to natural log. And notice this is absolute value of x. That's because we don't know technically if our x's are positive or negative, and natural log is only defined for positive arguments inside. So we have to make sure we keep that positive. And then plus c. So for our first one here, so we're going to do the odds again on this part. I would probably pull the 4 out to the front, and then this is 1 over x dx. So that fits our pattern. So this would be 4 times natural log of absolute value of x plus c. So very simple, just applying the rule. Number 9, you have a 1 over something, but it's not a 1 over x. So we're going to try to make it 1 over u du so that we can use our natural log property. So we're going to use our u substitution. So this is u is 2x minus 1. So du is 2 dx. So that means we only have a dx because the number on top here is a 1. So I'm going to replace it as du over 2 is dx by solving that over. So this would be 1 over my u times du over 2. Bring the 1/2 out to the front. So this is 1 over u du. This would then be natural log of the absolute value of u plus c times the 1/2 out front. And then we put back in our 2x minus 1 for our u. So our back substitution step. So 1/2 natural log of the absolute value of 2x minus 1 plus c. And then the last one for this part is going to be number 11. So let's look at, this is a little bit different because you notice you have a 6x on top. So anytime I see something with a quotient rule, I always try to break it up into 1 over the bottom times the top times the dx. And I try to see if I can do the u substitution and use my natural log integration rule. So this is u equals x squared plus 4, and du would be 2x dx. I have a 6x dx, so I'm going to times both sides by 3 to create that. So I'm going to be replacing my 6x dx with 3 du. So this equals 1 over u times 3 du. I would bring my constant 3 to the front. This is natural log of u when we take the antiderivative, plus c, and then we replace that back with the x squared plus 4. Now, technically, you don't have to use absolute value around x squared plus 4 because it's always positive. You could just use a parentheses, but absolute value is also correct, so there's nothing wrong with doing that. Okay, so that is the end of the pre-video for this section. It was actually shorter than I remembered, so you need to watch both of these, 5.2 and 5.3, and then remember that the rest of the notes will be covered in class by the sub. And then if you guys have any questions about anything, please, please, please reach out to me in email so that I can either create a video of something or try to help you work through the problem that you're working on. All right, have a good day.